Morning, everyone. Am I audible to you guys?
Yes, ma'am.
Okay. So yesterday we mainly discussed about RSA algorithm. So everyone clear about the process, how we do it? So today I'll start different algorithm, which is your Diffie-Hellman key exchange. So Diffie-Hellman is mainly based on your elliptical curve. Remember when we started with public key encryption, I showed there were different types of algorithms available for public key encryption, and the very basic one was RSA, then elliptical curve, and some others. So this is like the second one. Okay. Let me share my screen first. Okay, before I start that, I just confirm me once again that you are clear with RSA, the procedure. Okay, good. So, what is Diffie-Hellman algorithm? It's based on your elliptical curve cryptography. So, it's just type of elliptical curve cryptography. So, anyways, the main thing is that here it's like not based on your prime values, okay? And this involves mostly linear algebra. And the main point of this one is that they just try to find out a curve, and the curve we can just represent as this equation. This is the equation of any curve: y square equal to x squared ax plus b. So, and here it's like a and b are coefficients of x, and b is the constant. So since Diffie-Hellman algorithm is based on this something is wrong. Elliptical curve thing. So we just try to find out the values of A and B. Okay. And this algorithm actually provides like equivalent security with your RSA, even though key is small. So using this algorithm, even a 256 bit method means key can also provide almost like equivalent security with RSA cryptographic algorithm with 3072 bit key length. Okay. So if this is your curve, this red line is your curve. So here, and any curve you can represent with six tuples P, A, B, G, and H. So here P is the field that curve is defined over here. G is the generator point, A and B values define the curve. So Diffie-Hellman mainly tries to find out this A, B with which we can find define a curve. Okay. Then H is a cofactor. Again, yeah, some prime numbers are involved here as well. Here N is the prime order of G. So this is also kind of modulus operations are involved. So let's go to the algorithm directly. So this Diffie-Hellman algorithm is um, been invented, or you can say proposed by Diffie and Hellman around 1970. So this algorithm is being used to establish a shared key that can be just used for secret communication while exchanging data over a public network, using this elliptic curve to generate points and get the secret key using the parameters. So here we have to find out like two numbers will be available for users, both users. For example, P and G. Okay, that P and G will be available for everyone, or you can also say it will be like primitive root of your P, and there will be again involve shared uh, share I mean secret numbers for both client and the server, or you can say two users, which will be A and B. So this whole algorithm is based on four variables, P and G and A and B. So P and G are both publicly available numbers, and users will just pick up private values, which will be your A and B, and they will just generate key and exchange it publicly. And the opposite person receive the key, and from that generate class what accepted. Huh? Theta? After class. Class 10:15. Opposite person just receive the key, and from that generates a key, and after which they have the same secret key to encrypt. So if I just diagrammatically represent this whole thing, suppose there are two users, Alice and Bob. So there will be some common points which will be known to both Alice and Bob. Then there will be secret keys. Here I just represented secret color. So Alice and Bob will have their own secret. And from that, they will just create a different color by using modulus function, and they will exchange it. Okay, just go to the steps directly. So first what will happen, a public key will be available, E and G. So private key will be used by Alice, just example it's A, and Bob will also have a private key which is B. So how they will create the key, the function is this. It's just x is the secret key for Alice, and that you can just find out by G. G is publicly available, and G power of A is the private key, and they will just get the modulus function with P. So same thing, Bob will also generate his own key by using this expression or this equation. So here same again, it will take G and it will just find D of B, then mode B. After creating this key, both of them will just exchange that generated keys. So after exchange, Alice will receive the key of Bob, which is Y, and Bob will receive the key generated by Alice, which is X. So after that, again they will generate a secret key, which you can represent as KA. Then again they will use Y is the receive key. Then again will use their own private key to find a key. So similarly, Bob will also use the receive key and his own secret key to generate another secret key. Now algebraically, we can just show that K equal to K is there. Okay, so let's just see the example. It will be easier for you guys to understand. Okay, so let's just see the example for Diffie-Hellman. So just imagine you have Alice and Bob. Just take the same. Okay. So now for both parties, there are some known values. What are the known values? It's a modulus function, which is your P. For example, just take P equal to 23. Okay. Then there's again Z. Z, you can just say it's a base value, which is 5. So these values are known to both Alice and Bob. These are publicly available. Okay. Now Alice will have her own secret. Suppose secret is A. A is 4, and Bob will also have his own secret key. For example, 3. Okay. Normally this P and G both are prime numbers. Okay. Uh, this one again same prime number thing. So both P and G, those will be prime number and available to both Alice and Bob. And they will have their own secret. These secrets are not known to each other. It's just their secret. Okay. After that, what they do, they create a key, right? So for example, the key equation was G power A more than P. Okay, here I have written X and Y, it's fine. So suppose A, or you can also say X, is G power A, G power A mod of P. Okay, so what is G here? G is 5. And what is A? A is our 4 here. So it's 5 power 4 and mod P is 23. So if you calculate this value, the value will be, can you calculate? Just use your calculator. Okay, I just give the answer. It's 4. Okay. Then Bob will also create a key. For example, it's P, and B is again equation is same G, but the to the power is just its own secret key. So G power B and mod of P. Okay, so this one will be G is 5 again. Now B is here is 3 and its mod P is 23. So after this equation, the answer will be it answer is 10. Okay, so this is the key created with the help of P and G and its own secret keys for each other. Okay, so after creating this A and B keys, they will exchange it. So A or Alice will send this A secret to Bob, and Bob will also send his own generated secret to Alice. So it will send B equal to 10. So now here both have received their exchange keys. Now they need to find out what is the shared key. Okay. Now they will create another shared key which will be known to both parties. So I can just say shared key. The equation was y power a mod p. So you can say here b power y means here it's b power a is his own Alice's own secret, then mod of p is known to all again. So b is here receive key is 10. So this 10 again they will give the power with its own secret. What the own secret? A is 4. Then again mod is same 23. So answer for this is, so for here the answer is 18. 10 to the power 4, then you divide by 23 and remainder will be 18. Okay. Then here he will also create a shared key. Here the shared key again same. It will use the receive key which is A, and it will use its own secret key which is B, and just use the modulus function which is P. Okay. So this is the receive, this is its own secret, and this is mod of P. So received is A is 4 and its own secret is 3 and mod 23. So after this, what will be the answer? 4 power 3 divided by 23. What will be the remainder? The remainder will be again 18. Okay. So now we can see after exchanging the key, this is the answer. These keys are shared to everyone. So here we can show that if it's shared K, you can just say KA and KB. So your KA equal to KB. Okay. So this is the whole process. First, P and G will be known to both. They will have their own secret. Then they will generate the key. After generating the key, they will exchange the key with each other. So after exchanging the key, they will again create a key which will be equal to both. That means for the opponents, even they do know this P value and G value, they don't know about A and B. Therefore, uh, it's a very good encryption method and secure method because it's very difficult to keep guessing on the values of A and B. Again, the point of sharing is even they know the point of sharing, but they won't be able to again generate this shared key. So both parties have a shared key, but to generate this shared key, they are using their own private key and the public keys. Okay. So this algorithm is widely used in many places, but somehow RSA is more popular. And the advantage here is that even using the small number of keys, you will get a very equivalent security of like RSA with higher key numbers. So that's all about Diffie-Hellman. How we generate. Is this one clear? The process? Here I have taken just small numbers. So obviously when we practically someone will use it, they will take like very big numbers. The prime numbers have to be like very big, then only it will be really secure, right? So for simplicity, you can just show it this way. Yeah, just make sure this P and G values are prime. Okay. Just remember the steps. P and G available to all. They will have their own keys, A and B own secret. Then They will just create key, exchange the keys, and after exchanging key again will create a key, and that key will be same for both parties. That's how they just exchange their keys or a shared information. Any confusion with the process? It might seem a bit complicated when we use like really big numbers, but the fundamental part is like not so complicated. It's simpler than RS, I would say. Any confusion? So no confusion? Okay, if no confusion, someday I'll just take surprise test. Then it's not like I'll just conduct the test in like Google Classroom. I'll just ask questions one by one, and you have to answer it. If you can't answer, then you won't get attendance. Then let's see what I'll do with you guys. Okay, is it clear? Okay, that's all for today's class. Okay, thank you all.